Hello, and welcome to our next exciting lesson in math. We're going to continue our proportions lesson, and we're going to be talking about scale drawings. What are scale drawings? Scale drawings are things, and you see them all the time. An architect is building a house. He has to do a drawing before he actually builds the house. Can you imagine what would happen if he just tried to build a house without having a plan first? A scale drawing simply means that we cannot draw that house to normal size, because we don't have enough paper and it wouldn't make sense to try to draw it this actual size. So what they do is they make it smaller using ratios and a proportion to say, okay, if I want it to be this tall in real life, it's going to be this tall, and using that same ratio to draw all the other aspects of the house. So I put two examples here. The first example is like a rendering or a scale drawing of a house, and the second one is a scale drawing of an old-fashioned airplane, the B-52 bomber. So you can see when this would be useful. There are a lot of situations in which you would use scale drawing, and we're going to talk about them more as we move into this lesson. Okay, our learning target is to apply proportions to solve practical problems, including scale drawings. And if we dive right into the notes, this is on page 8, our scale drawing notes. Scale drawings, they're the types of proportions that show something that is too big or too small to be drawn its actual size. And so some examples that I was talking about, and you can put them over here, means drawing a house. Drawing something like buildings, cars. Those are things that are too big to be drawn actual size. But then if you think about something that's too small, what if it's a scientist and they're trying to map out a cell? You guys just studied cells before the holidays, and you guys talked about the different parts of a cell. The scientists are the ones that make those discoveries, and in order to show what they actually look like, to talk about their size, they have to use a ratio. That ratio is called the scale. And so when you look at a map, when you're driving in your car and you're taking a vacation, you're going to see on your map, it's going to tell you scale, and then it'll tell you 1 inch equals 25 miles, or 1 inch equals 4 miles, or 1 inch equals 10 miles, depending on the size of the map. And that scale is going to change based on what you're drawing. And like I said, there's some different things here. The first one is a scale drawing of a house. This is the kind of problem situation you might see on your SOL. I showed a picture of a cell with the nucleus, because those are really, really, really tiny, and you can only see them through a microscope. But when they draw them, especially if you're talking about in medicine or something, and they're looking to see is the size of a cancer cell shrinking or something, they have to use those ratios to compare them. And then I put the space shuttle because that's another practical situation. If you've ever been to the Air and Space Museum in DC and seen how big that is, you would understand. Okay, so the other piece is how do I know it's a scale drawing or a scale problem, scale proportion problem? Most of the time you're going to just look at it and solve just like any other individual look, because it's just like any other proportion problem where they give you 3 values and you're just plugging them in. With scale drawings, I like to tell my students to keep the scale or the map or whatever on one side and the actual values on the other side, and kind of set up a table of proportion. So if you look at this example that we have, it says on a map, so we know it's on scale drawing, the distance from Chicago, Illinois, to Mexico City, Mexico, is only 10.9 centimeters. We know that going from Chicago up by Canada, the Great Lakes, and down to Mexico City in Central America, that's a long distance. So if we look, the scale that they used was 1 centimeter equals 250 kilometers, and they want you to find the actual distance between the two cities. So again, like I said with proportions, you want to make sure your answer makes sense. So if you get a really small decimal answer, is it going to make sense that that's the kilometers? No. So if we know that 1 centimeter equals 250 kilometers, we know that 10 centimeters is going to equal thousands of kilometers. So you're looking for an answer that's in the thousands. You get something that's smaller than thousands, then you're set up the proportion wrong. So first thing we want to do is we want to highlight the things that we know. We know that on a map, the distance is 10.9 centimeters, and we know that the scale is 1 centimeter to 250 kilometers. So when we're setting up our proportion, I like to say, let's put scale on one side, and let's put the actual distance on the other side. And then look at the two units that we're lining up, centimeters to kilometers. And then you can kind of draw, almost like you guys are studying Punnett squares in science, almost like a Punnett square kind. We got centimeters on top with the scale and the actual, but then kilometers on the bottom with the scale and actual. First thing you do, plug in your scale. It's given to you. 1 centimeter equals 250 kilometers. And then look at the other actual, what's given to you. I have centimeters, 10.9 centimeters. And I don't know, I'm trying to find the actual distance in kilometers. The next thing we have to do is set up our equation. You're just going to simply take this, cross multiply. And when you set up your equation, you get 1x is equal to 2,725. Anything divided by 1 just equals itself, so x equals 2,725, and that is kilometers, because if I look across my units, my x is under kilometers, so I know that that's my solution. So that takes care of cross multiplying and getting the variable by itself by using division. And what I wanted to show you down here below, we have Chicago, for those of you that have never been there, is right here. And Mexico City is all the way down here. You can't see it, but it's in the middle of Mexico. So we're talking about driving all the way down here. So that's what we're saying. It's going to be 2,225 kilometers. But it makes sense. If 1 centimeter equals 250 kilometers, then I would get less than 250 kilometers, and it's a really far distance. No, that's where you have to make sure your answer makes sense. And if you look at this map that I downloaded off the internet, you can see the scale is right here. And what you have to do is use a ruler to say, okay, how far is the distance from here to here, using a ruler, and then set up your own ratio, because that equals 2,000 miles. So that's the kind of thing that you would use in real life to set up how long is it going to take us to do our trip, or so on and so forth. Okay, the other kind of scale drawing questions is something like this, where it says a tree is 30 feet high and creates a shadow 25 feet long. At the same time, if a person casts a shadow 5 feet long, how tall is that person? So that means that if I have, I'm going to draw pictures because I'm a visual learner. So I've got this tree here. And it's saying that my tree is 30 feet tall. And it casts a shadow that is 25 feet long. So they're saying that here's my height of my tree and here's my shadow. And then it's saying at the same time I've got this person over here. And we don't know how tall the person is, but we do know the person casts a 5-foot shadow. So now I just need to find out how tall they are using a proportion. Again, I've got the tree here, and I've got the person right here. We're going to set up just like we did before, kind of almost a Punnett square kind of thing. We have their height on top and their shadow on the bottom. It's all in feet. So if you look, feet, feet. So this is where you have to kind of break down the problem. So the height of the tree I know is 30. The shadow of the tree was 25. So let's look at the relationship. Tree is taller than its shadow. So if I know that the shadow is 5 of the person, I know that their height, if I'm following the same proportion, looking at the numbers, the number on the bottom is smaller than the number on the top, so I know that they have to be taller than 5 feet. So all I'm going to do is cross multiply to set up my equation. 25 times x is 25x. 30 times 5 is 150. And all I have to do is divide by 25 to solve my equation. And I get x equals 6 feet. So I know that the person is 6 feet tall. And I can plug that back in and say, okay, does that make sense? That 5 is smaller than 6, 25 is smaller than 30? Yes. If I look at it that way, my answer does make sense. So I would be confident in the answer. Here's another example of one. Phil is building a scale model of his home. So he's making the actual model. Those of you that like to create toy models of cars or planes or something, they're based on the real thing. So they take the ratio and we just shrink everything down. And that's what he's doing. He's making a scale model, which is a smaller version of his actual home. And it tells you his actual home is 26 feet wide by 40 feet long. And he's making his model is 10 inches long, and they want to know how wide is it. So again, I'm just going to set it up. We've got the actual, that's given to us, and we've got the model. And the two things that we're comparing is the length and the width. So let's make this a proportion. The actual home is 26 feet wide. Oops, I got that please. Easy mistake to do. I'm using the same colors that I used before. 26 feet wide, 40 feet long. So now I'm going to plug in 10 inches long, and I want to know how wide. To solve, let's multiply. Set up the equation. So I have 40 times x in the same circle, and I have 26 times 10, which is 260. To solve, that's a one-step equation. Undo the multiplication with division. And my answer is a decimal, 6.5 inches. Not inches. Yep, it is inches. Sorry, because it's his model. So again, I'm going to plug that back in and make sure it makes sense. If 40 is bigger than 26, then my answer should be smaller than 10. Is my answer smaller than 10? Yes. So I can reasonably say that makes sense. So again, you're just taking the pieces, plugging them back in, kind of making a plan as you do so. Alright, these are the last two examples I'm going to do, and you're going to do 3, 4, 5, and 6 through your Edmodo quiz. But let's look at some more examples. On this one, I can assume I've got Los Angeles and San Diego, California. It's talking about a map, so I know I'm looking at a map and it gives me the scale. So always start with your scale. If you've got a scale, just write, I've got centimeters over miles. So my scale is 1 centimeter to 20 miles. You don't have to put your centimeters. You can just put 1 to 20. And then on the other side is the actual distance. So I know that it's much bigger. So that on the map, the distance is 6.35 between the two cities, and I want to figure out how many miles is it. So if you look at this, the top number is a lot smaller than the bottom number. So if it's the same proportion, then my bottom number should be a lot bigger than 6. So let's cross multiply. We have 1x on the one side, and then I have 20 times 6.35, which is 127. Anything divided by 1 is just going to be the same thing. So I know my answer is 127 miles. Now let's look and make sure that makes sense. Is 127 a lot bigger than 6? Yes, so my answer makes sense. If you wanted to, you can plug it back in here and then cross multiply and make sure your answers make sense. And they should be the same. Okay, the last question we're going to do, scale is 1/2 inch to 4.5 miles. So here's my scale, that's the first half of my proportion. And I want to turn that half into a decimal. So take 1 and divide it by 2. And you get 0.5. Remember, half is just 0.5 or 50%. And it's over 4.5. That is inches over miles. And then the actual distance that they give me in the problem is the distance was 2 3/4 inches. Again, I need to take this and turn it into a decimal. So you can either do the magic C, 2 times 4 is 8, plus 3 is 11 over 4. And then divide, and you're going to get 2.75. Or just take 2 and then divide 3 and 4, and you still get 2.75. And I need to figure out the actual distance in miles from Simon's hometown to Cincinnati. Okay, looking at my first ratio, I have 0.5 and 4.5. So I know that my number on the bottom has to be bigger than 2.75. So let's cross multiply. And we cross multiply, we get 0.5x. And then I have 4.5 times 2.75, and I get 12.375. To solve, I divide by 0.5, and I'm dividing by the number with x. Those cancel, and I'm left with 24.75 miles. And again, just plug it back in, make sure it makes sense. Is 24 bigger than 2? Yes, so it makes sense. So that's all you're doing, simply just proportions. And with scale drawings, I like them because the scale is usually presented right there, nice and easy. The only one you have to be tricky that can trick you up is the trees and the shadows. But if you draw pictures, it's kind of already there. You look, I have 30 over 25, which is my first ratio, x over 5, which is my second ratio. So you draw a picture, it kind of already sets up your proportions for you. Okay. The rest of the problems, like I said, numbers 3, 4, 5, and 6, you're going to complete in your quiz in Edmodo. Make sure you go ahead and do them, solve them on your paper right now, and then you can log in and complete the portion or the quiz on Edmodo. Have a great afternoon.